Welcome to video 5.3D, another proof with parallel lines. So here's example 3. I'll mark up the diagram as I give you the given. So we're given circle O with AD parallel to CB. Again, I like to extend those parallels. AD parallel to CB. Prove that OD is congruent to OC. So prove that that is congruent to that. So right off the bat, I'm looking to get these triangles congruent, and once I get the triangles congruent, I'm looking to get those parts congruent. Okay, so now let's go back to chapter 3 and see how we can get the triangles congruent. Without much effort, I know I can get those vertical angles to be congruent. Without much effort, I know I've got radii that are congruent. So I'll get this segment over here to be congruent to this segment over here. So now I'm looking for either ASA or SAS. With the parallel lines, typically I can get angles, so let's see if I can do that. So if these are the two parallel lines, let's see, I could have the transversal be either here or here. I'd love to have that angle, so I could get angle side angle, so I will make that be my transversal. So if that's my transversal, I will be able to get this angle here congruent to that angle there. They're on the interior and alternating sides of the transversal. So based on that, angle side angle. I now have clear direction. I'll just write down angle side angle as my guideline, and now let's do the proof. All right, so I'll go in angle side angle order. So I'll start with the parallel lines and then get the alternate interiors. So I've got AD is parallel to CB. That was given. And then based on that, I'm going to get this angle A congruent to angle B. Angle A congruent to angle B. If lines are parallel, then alt interior angles are congruent. Okay, I'll mark that up. That's my angle. Then I'll get my side. My side stemmed from the radii, so I'll have to now state the circle and then the radii. So I'm given circle O, and then from that I'm going to get the radius. AO is congruent to BO. If radii then congruent. And then I'll use the vertical angles for my final angle. I have to use 3 letters here. Angle AOD is congruent to angle, I'll go BOC. I'll say if vertical angles then congruent. Now I'll get the 2 triangles congruent, just so you can see the triangles better. So I'll say triangle AOD is congruent to triangle. Let's make sure I did my lettering correct. A to O, B to O, okay, BOC. That's by ASA. And then once I get the triangles, I can get the parts. The parts I care about OD. So last 2 letters and last 2 letters, and that makes sense. So OD is congruent to OC by CPCTC. So there you have it. Another proof involving parallel lines.